Okay, so I promised you to do regression trees in the previous video, but I didn't have time and enough for the previous video. I'm only allowed to do 15 minutes per session. And here we're gonna do decision trees for regression. And again, here I've written some code like to split the data. We are going to use the Boston data, and we want to predict the median value for the houses in Boston based on different variables. We discussed this data set before. This data set is part of library mass. So I'm going to attach it. And then, since again, remember that once we want to use a function that depends on a random number generator, we have to probably select a seed to start with if you want to reproduce the same results later on. So here we are splitting the data set into training and testing based on these conditions. Now we have the training data is here, and the testing data is saved. We are also gonna do a testing median value. Median value is the y variable that we are trying to predict, so we need to save it in another vector. And again, as I always say, if you want to refer to what's happening here in details, please look at previous videos. Now in these videos we are just more focusing on decision trees. Since we are going to use decision trees, we probably need the library called trees, and I'm gonna load it now. Alright, so now it's time to fit regression. Maybe I'll show you very quickly how the Boston data look like. So we have different variables, and this is the y variable we are trying to predict based on the other variables. All of the variables that we have here are numerical, and we want to do regression. So, and this is numerical here, median value, so we're fine to do regression for decision trees. So here, fit a tree based on training data first. So I'm gonna call that tree model tree using the tree function. In the tree function, we're gonna specify, the model. So we are predicting median value from all of the predictors. When we use a dot, this means that we're using all of the predictors from using the training data. Now we created the model. If you want, sometimes you can see maybe if you print the tree model, if you just print that, if you can see here, it's giving you a summary of each of the nodes that you have. So what this tells you that first of all, it's telling you that LStat is the most significant variable in the tree because it starts splitting on LStat. And so in this node, it contains 103 observations, and this is the deviance here, and the y value here, it's showing you that it is 30.13. So it's predicting that the y value for that node is in case the LStat is less than 9.715, it's going to be 30.13, and so on. We can also plot the tree model just the same way we did in the classification. It's going to produce the tree here. We can add the text for the tree model. Here we don't have to worry about adding the pretty equal to 0 to this text because we don't have categorical variables to care about in our data set. But if there were some categorical variable, then we need to put this. But let's do it, to be on the safe side. All right, so here we plotted the data. Well, let's see how this model is doing before pruning it. So check how the model is doing using the testing dataset. Alright, to do that, we are going to do prediction. So let's see, 3 predicted. I'm going to use a function predict to do these prediction. And this predict, we're going to predict using the model, tree model that we created here on the testing data. That's it. We are going to create the predictions. You can create your confusion matrix using the table command tree predict, and then again we are testing that against these median values, the actual ones. So this are the predicted, these are the actual ones. Oops. What's happening here? Did we run tree predicted? Oh, why we are using like that's why are we using this? Because we are doing regression here. We know we could, like, only in classification we would check what, you know, the actual and the real, so it doesn't make sense to have a confusion matrix. But we can look at the mean squared error, which is the difference between what we predicted, so tree predicted, minus the testing median value, and it's going to be squared. So the mean squared error is going to be the difference between these two squared. It gives you a 25.04. Alright, so that's the mean squared error. Let's see if we do pruning, we might be able to achieve probably a better mean squared error. We might not be able to reduce that. So let's see what would happen. Again, in order to check, to do pruning, we have to check, you know, what would be the level that we want to reach, what would be the size of the tree we want to get. And when we say size means that the number of leaf nodes that we have here. So let's do cross-validation for pruning the tree. Again, the same as we did, the same thing we did for classification. We are gonna use the function cv.tree and use it to do pruning for the tree model we created here. This cv underscore tree object is gonna have you know, the different sizes of trees with their corresponding, you know, error rate. So or MSE in this case, if we're looking at regression, we can plot cv underscore tree size. That's going to be our x variable, cv underscore tree. Let's remember what would be the names of that. cv underscore tree. We are looking at size versus deviance in here, which is the mean squared error. So cv3 deviance. And you know, the type of the plot, we're gonna use B in order to connect, or you can use L in order to connect all of the dots together. And B would connect the line, would connect the dots together and keep the dots on the plot. In addition to that, we can add a label for the x-axis. X-lab would be the tree size. It's a good practice to label our axes, and Y-lab would be the MSE. Let's do the plotting. So based on this here, we can see that if we want to achieve a minimum MSE, the tree size would be, you know, 7 or 8. We can use actually, you know, indexing criteria. We can look at which dot min, what would be the minimum among the MSEs. That will give you the index of the MSE. Now, if you want to look at, so it's at index 1, right? So this means that if you want to see what would be the size, so you're going to look at CV underscore tree, and size, we're going to refer to 1. This means that it is of size 8 and not of size 7. So again, it doesn't make sense to do pruning here. But let's say that we decide to do pruning on 7 just for the purpose of video here, recording. Let's do pruning. So the prune the tree to size, maybe let's look at 4. So we have the pruned model is equal to, let's see, prune dot tree. This function will prune the tree, the regression tree, and so the regression tree we created was tree model here. And we are gonna specify, what's the best model. Let's say that we decided the best was 4. It's actually not gonna change anything because this is not the minimum MSE. But as we said, let's see what would be the result. We would, think that it should give you a higher MSE than the non-pruned one, because the non-pruned one is of size 8, and this size 8 was the minimum MSE. Plot the pruned tree. Did we run? Oh, pruned model here. We called it model. And then you can add text to it. Which tells you, remember that this text tells you that if else stat is less than 9.7, if that condition is correct, then we're going to go to the left. Otherwise, we're going to go to the right, and these are the predictions from the tree. So if else stat is less than 9.7 and the room size is less than 7, then we predict that the median price value would be 27. Well, if it's recorded maybe in thousands or whatever, then we have to make sure that the unit we're using is appropriate in this case. But anyway, so this is the pruned model. Let's check how it's doing. Check the model or the accuracy of the model. Using testing data. Alright, so we are going to predict first. The same thing we did earlier, predict. Using now the pruned model instead on the testing data. And now we can find the mean squared error, which is the mean of the difference between the predicted value here and the actual value, which was, what was the name? Testing underscore median. You can just copy it. And then that is squared. As we expected, it's not going to reduce the MSE because we saw that the minimum MSE we can get is when we have the full tree without pruning. So in this case, pruning does not help. So that's just an example that tells you that, pruning might help sometimes, might not help, but we can check, using cross-validation. Cross-validation is going to, tell us what would be the best size of a tree. Anyway, so I'll probably record random forests next, so good luck.